Okay, ladies and gentlemen, welcome to part 3 of the Integrated 1 first semester final exam review. Okay, so for this part 3, I will be starting at problem number 42 and going all the way up to problem number 59. So here we go. Number 42 says, find the x-intercept and the y-intercept of the line given by negative 7x plus 6y equals 42. Okay, so real quick, let's just recap what an x-intercept and a y-intercept are. Okay, so here's a coordinate plane. And if I have a graph, a line that passes, let's say that way, okay, the x-intercept is this point right here where my line crosses the x-axis, and the y-intercept is this point right here where my graph crosses my y-axis. Okay, and what's special about those 2 points is that the x-intercept will always have this format. It'll be x, whatever the value of x is at that point, 0, and the y-intercept will always have this format. It'll be 0 and then y, which is whatever the value of y happens to be at that point. Okay, so using that knowledge, I can come up with the x-intercept and the y-intercept by simply substituting in 0 into my equation. Okay, so let's start with the x-intercept. For the x-intercept, I want the y value to be 0, so I'm going to substitute in 0 right here, so I could find, right here into the y value, so I could find the x-intercept. Okay, so here we go. It's going to look like this. Negative 7x plus 6y equals 42, and in place of y I am going to substitute in a 0. So it's going to look like this now. Negative 7x plus 0 equals 42, which basically means that that cancels. And then it's a simple one-step equation. Divide by negative 7 on both sides, and you are left with x equals negative 6, right? 42 divided by negative 7 is negative 6. Okay, and that is your x-intercept. The y-intercept, it looks like this, right? 0, y, where y is the value of the y-intercept, and the x value will always be 0. Okay, so we're going to do the exact opposite of what we did. We're going to substitute in 0 for x, and then solve for y. So here we go. Let's do that one. It's going to look like this. Negative 7x plus 6y is equal to 42. In place of x, I am going to substitute in a 0, which basically means that this is going to cancel, so all you have is 6y is equal to 42. Divide by 6, and y is equal to 7. And that is your y-intercept. Now, a common mistake that people make is that they will put the x-intercept and the y-intercept together, and they'll write it as a coordinate pair like this, negative 6, 7, and that would be a pretty big mistake. Okay, that is not the x-intercept or the y-intercept. That is just a point that is on the graph somewhere else. Okay, so do not combine the x-intercept and the y-intercept. They are separate from each other. So you're either going to write it like this, x-intercept equals negative 6, just simply write negative 6 right here, and y-intercept equals 7, or you're going to write each one separately as its own ordered pair. So for example, for the x-intercept, it'll be negative 6, 0, and for the y-intercept, it'll be 0, 7, and that would be the correct answer. Okay, never write it like that. All right, let's move on to number 43. It says find the indicated intercept of this function. So part A says find the y-intercept of negative 2x plus 5y equals 30. So let's start there. First, let's recall that the y-intercept always will look like this. Okay, it'll be 0, y. 0 for x, and then y, whatever the y value it is that we come up with. Okay, so using that, I am going to substitute in 0 for x. Plug in 0 right there, which means that cancels, so I get 5y equals 30. And then I can solve that simply by dividing by 5, which gives me y equals 6. Okay, now to write my answer, I'm going to write parentheses 0, 6. And that is correct. All right, we move on to B. It says find the y-intercept of y equals 5x plus 50. So once again, the y-intercept, just like in the last one, so it's going to look like this again. We're going to substitute in 0 for x and solve for y. Okay, so let's substitute in 0 for x. So it's going to look like this. Y equals 5x plus 50. Instead of x, I am going to substitute in a 0. That basically goes away, so you get y equals 50. And so your solution is 0, 50. Okay. So the work that I just did, some of you guys are going to think, well, that was useless because it was just right there, right? Some of you guys might have noticed that this is written in slope-intercept form, and when they give you the equation in slope-intercept form, this first number next to the x represents the slope, and this final number, which is b, right, represents the letter b, is the y-intercept. So you could have just said the y-intercept is 50. Okay, so you could did it that way, or you actually substituted in 0, in which case you got the exact same answer. All right, and finally part C is asking you to find the x-intercept of this equation right here. So once again, the x-intercept is going to look like this, x, 0. So that means that we're going to substitute in 0 for y and then solve for x. So it will look like this. Negative 4 over 5x minus 3 over 2 times 0 is equal to 72. And then 3 over 2 times 0 will just go away. It's nothing. It's 0. So you have negative 4 over 5x is equal to 72. Okay? And now you have to solve that equation. Okay, so let's recall our how to solve equations. When you have a fraction in front of the x, the fastest way to get rid of it is to multiply by the reciprocal of that fraction. So what I'm going to do is I'm going to multiply both sides by the reciprocal of negative 4 over 5, which is negative 5 over 4. So it looks like that. And then what's going to happen when you multiply negative 4 over 5 times negative 5 over 4 is that the 5's will cancel, the 4's will cancel. Negative times negative right here will be positive. So all that is left is x. Right? The negative and the negative will become positive. So what will be left? Just simply x. On the right side, you will have to do a little bit more work. Okay, so you have 72 over 1 times negative 5 over 4. First of all, that's going to be negative because it's a positive times a negative. And then you could multiply that out using your rules of multiplying fractions, right? Straight across, no fancy stuff, unless you see that something that you can cancel. Okay, so what I'm going to do here is first multiply 72 times 5, which is negative 360. And then 1 times 4, which is 4. And then the last thing I'll do here to finish is to divide 360 by 4. And that is going to give me negative 90. So that's your x-intercept. We're going to write it in the correct form, which is as an ordered pair. It'll be negative 90, 0. And that is your final answer there. All right, here's number 44. It says the graph below shows the change in altitude during a 30-minute hike. Okay, and part A, section A says find the rate of change of the hiker's altitude for each section round to the nearest tenth. So for each section that is labeled here, section A, section B, section C, D, and E, we will have to find the rate of change. Okay, now the rate of change, if you recall, in a graph is basically the slope. Okay, the rate of change is the slope when we're talking about a graph, how steep the graph is. So we're basically, in this case, looking for the slope for each section. And each section is going to be different because they all look like they have different steepness, right? So let's start with section A. Section A, what I'm going to do for that section is find the beginning point and the ending point and use those 2 points to find the slope. Okay, so for example, right here at this beginning point of section A, that is 0, 1600. And the ending point of that section, right here, the end point of that section is, looks like it's going to be, it's going by twos, right? So it's going to be 8, 10, and so on. So this is 8, 1400. And then you're going to find the rate of change using those 2 points. Now there's various ways for you guys to find the rate of change or the slope, right? You could use the slope formula. The way that we like to do it, or I like to do it in my class, is to just simply find the change from one number to the other. So for example, from 0 to 8, figure out how much the number changed by, and you're going to say that that changed by 8 plus 8. From 1600 to 1400, what was the change there? And you're going to say, well, that went down 200, so minus 200. And so therefore the slope is going to be negative 200 divided by 8. It's always going to be the change in y divided by the change in x, right? That is the definition of the slope or the rate of change. The change in y divided by the change in x. So negative 200 divided by 8, go ahead and do that simple division real quick, and you will get negative 25. Okay. All right, moving on to part B. Looking at part B, I can see that the beginning point is the same end point of part A, so 8, 1400. And the ending point of part B is way down here. So since this is going by 2's, this is 14, 400. All right, and once again, I'm going to find the rate of change by just looking at how the x's are changing and how the y values are changing. Okay, so let's see. From 8 to 14, it looks like it increased by 6. From 1400 down to 400, it looks like it decreased by 1,000. So your slope is going to be negative 1,000 divided by 6. Always change in y divided by change in x. So negative 1,000 divided by 6. If you leave it as a fraction, it's going to be negative 500 over 3. That's a negative sign right there. Over 3. Or as a decimal, it'll be approximately negative 166.666666 is a repeating decimal. Let's leave it to one decimal place. Approximately negative 166.7. Okay, so using that same strategy, I'm going to let you guys go ahead and find the rate of change for section C, D, and E. Okay, so go ahead and pause the video, do the work, and then come back to check your correct answers. Okay, pause the video now. Okay, so here you go. These are the correct answers for part C, D, and E. Okay, using the same strategy that I used before, the rate of change in section C is 0 because it's a flat line. Horizontal lines always will have a slope of 0. Section D will have a slope of 40, positive 40, and section E will have a slope of 150. All right, let's move on to problem number 45 then. It has two parts, so what I'll do is I'll do part A and then I'll let you guys work on part B on your own, okay? So it says find the slope of the line. So I'm looking for the slope of this line right here. They have already basically labeled 2 points for me. Okay, that's not always going to be given to you. You're going to have to find those 2 points, identify 2 points on your own most of the time. In this case, they gave me those 2, so I'm going to use those 2 points. Okay, first thing you do is find the coordinates of those 2 points. So the first point right there is negative 1, negative 2, right? The x value is negative 1 and the y value is negative 2. The second point there is positive 2, the x value is 2, and the y value is negative 1. So that's the first thing you should do every time they ask you to find the slope. Identify 2 points. Doesn't matter what information they give you. They might just give you the 2 points. They might give you a table. They might give you a graph, but you need 2 points. Okay? Using those 2 points, you can use the slope formula, in which you're finding the rate of change. Okay? What I like to do to find the rate of change is just put them on top of each other and find the change that way. Fix that. Negative 1, negative 2, and 2, negative 1. Okay, and what you're doing is you're finding how the x values and the y values are changing in order to find the slope. Okay, so let's start here with the x values. From negative 1 all the way to 2, What's the change? How much is it changing by? Okay, and you should say plus 3, right? From -1 all the way up to +2 is going to be plus 3. Okay, and the rate of change from -2 to -1, you're finding how it changes by. So from -2 to -1, what's the change there? And you should say, if you're thinking of this correctly, you should say +1, not -1. Okay, remember I always tell you guys, picture a number line when you're thinking of these rate of changes. You're going from -2 all the way up to -1, so you're moving to the right one. So what's the slope using those two numbers? The slope will be 1 over 3. Okay? Always change in y over change in x. So 1 over 3 is your slope. Okay, so using that same strategy, go ahead and try part B on your own. Okay, so check it, do it first. Pause the video right now so you can do it on your own and then come back to see the correct answer. Okay, pause the video now. Okay, so here's the correct solution for part B. Using the 2 points -4, 1 and -2, -2, I see the rate of change for the y's is -3, right? It's going down 3. And the rate of change for the x's is +2. So making a fraction of those, change in y over change in x is -3 over 2. All right, so 46 is the same question. So once again, I'll use this exact same strategy. I'm going to find 2 points and I'm going to find the rate of change that way. Okay, so in part A, there's 2 points labeled for me, although there's plenty of points to choose from here, right? You could use any of these points up here, this one or this one or this one. There's so many points to choose from. So just, I'm going to use the 2 that are already highlighted there for me. The first point I see is 1, -2, and the other one is 1, -3. Right, so let's do it over here. 1, -2 and 1, -3. Find the rate of change there. From 1 to 1, 0, right? Nothing changed. From -2 to -3, it's -1. Using those two numbers to find the slope, I come up with m equals -1 over 0, and that automatically turns on the warning lights, right? That's not possible. We cannot ever divide by 0, okay? That is an actual number that does not exist, so we're going to say that the slope here is undefined. Okay? And that's something, a basic fact that you should know. All vertical lines have a slope which is undefined. All right, part B now. Using those 2 points, I have 0, -2, and 1, -2. Now in this case, the change in the x's is from 0 to 1 is +1, and the change in the y's is +0, right? No change there. Therefore, the slope is 0 over 1. That one is not undefined. That is an operation that we can actually do. We can do 0 divided by 1. That works. How many times does 1 go into 0? You're going to say none. So the slope here is 0. And that's another fact that you should know. All horizontal lines will always have a slope of 0. Okay, and that's the big difference between horizontal lines and vertical lines. Horizontal lines, you can walk on it, okay, but it's flat, so it's 0. Vertical lines, you cannot walk on that, so it's undefined. Okay, 47, A, B, C, and D are the same question. Find the slope of the line passing through this pair of points. I'll do the first one, but I'm going to let you guys do the last 3. Okay, so here we go. 9, -4, and -10, -4. First thing I'm going to do is stack them. You know what? No, I'll do it down here. 9, -4, and -10, -4. Find the rate of change right here with the x's. And by the way, there is no rule. You've been noticing that when I draw my arrows to find the rate of change, sometimes I'm going downwards, okay, Sometimes on that one I went downwards as well. Sometimes I choose to go upwards, as in section part D right here, right? It doesn't really matter as long as you're consistent. Do the same thing on both sides and you're okay. So in this one, let's go upwards, just so we can say that we've done both possibilities. From negative 10 all the way up to 9, be careful with those. Those are the ones that people most of the time will get wrong because they make a little mistake. Think of a number 9. You're at negative 10 and you want to go all the way up to positive 9. You went up you went up 19. Right? And for the y values, from negative 4 to negative 4, you went nowhere, right? 0. Therefore, the slope is 0 over 19, which makes 0. 0 in the numerator is okay. 0 in the denominator is not okay. Okay, so this one's fine. It's just 0. Okay, so you try B, C, and D using the exact same strategy. Okay, so try them on your own. Pause the video and then come back to check your answers. Okay, pause the video now. Okay, so here we go. These are the correct answers for B, C, and D. In B, you have 7, 9, and negative 2, negative 4. The rate of change on the x's is 9, and on the y's is 13, plus 9 plus 13. So your slope is 13 over 9, which you cannot simplify any further, so that's fine if you leave it like that. Okay. In C, negative 8, negative 2, and 6, negative 7, the rate of change, the change in the x's is plus 14. I'm going downwards. And the change in the y's is minus 5. So it's negative 5 over 14. And once again, it cannot be simplified. And in D, you have 6, 10, and 6, 5. The change in the x's is 0, and the change in the y's is plus 5. So you get 5 over 0. Maybe some of you guys got negative 5 over 0, which doesn't make a difference because every time you try to divide by 0, you're still going to get undefined. Okay, so that is your solution for that one. Okay, 48 says find the slope and the y-intercept of the graph of the linear equation, then graph the equation. So both of these are in slope-intercept form. So that's what I'm going to start with by writing my general form for slope-intercept, y equals mx plus b. Right, something that all of you guys are familiar with. In slope-intercept form, the m represents the slope, and the b here represents the y-intercept, where it crosses the y-axis. Okay, so to find the slope, you just have to look at the x term, and whatever the coefficient is, whatever the number in front of it is, that is the slope. So in this case, if I look at this, here's x. It's in slope-intercept form, right? First compare it. Y equals mx plus b. Here's x. So the number here next to x, the coefficient, is the slope. When you don't see a coefficient, it is assumed that the coefficient is 1. So in this case, the slope will be 1. The y-intercept is the number here at the end, the plus b. So in this case, it's plus 4. So the y-intercept is 4. Okay. Go ahead and do part B then on your own, okay, using the exact same strategy. Okay, pause the video, do it on your own, come back and check your answer. Okay, so here's the correct answer for part B. The slope is 3 over 4. Yes, as a fraction, that is the number that is in front of the x, that's the coefficient. And the y-intercept b is 5. Okay, so part 2 of this question is asking us to graph them. Okay, so let me show you how I'm going to graph mine, and then you will graph part B again, like we did in the last time. So the slope is 1, the y-intercept is 4. What we're going to do is begin with the y-intercept. Remember, it's y equals mx plus b, as shown here, right? Y equals mx plus b. Think of b as your beginning, and think of m as your moving, right? It's instructions to move. So b is 4, right? The y-intercept is 4. So we're going to begin at 4 on the y-axis. Always on the y-axis if you're getting slope-intercept form. Then I'm going to use the slope, which is 1. I'm going to turn it into a fraction, 1 over 1. And that tells me where to go, right? The top number, the numerator, tells you the directions of the vertical directions, up or down. The denominator tells you the horizontal directions, left or right. So in this case, it's telling me to go up 1 to the right 1. So using that, I'm going to go up 1 to the right 1 to right here. And that's enough to draw your line. It's always suggested that you do more points, more than just 2, just so you could have a straight line that you know which way it goes. Now I'm out of space up here, but I can go downwards. I could go down 1 over 1 and so on until I find more points to graph. So it'll go here, and it'll go through here, and here, and here, and here. And then I could draw my line. There you go. Okay, your turn. Graph the other one. Pause the video now, graph it first, then come back and check the answer. Okay, here you go. This is the correct graph for part B. The y-intercept is 5, so I began up here at 5. And then the slope is 3 over 4, which is telling me to go up 3 to the right 4. But since I'm out of space here, I can't go up 3 and to the right 4. So what I did instead is do the exact opposite, right? If you're going to go up 3, right 4, it's the same thing as going down 3, left 4. Right? It's like thinking of it as negative 3 over negative 4, which still is positive 3 over 4. Okay, so down 3, left 4, and there is the point right here, and then you connect them to make your line. Okay, here we go with number 49. It says to write the equation of the line in slope-intercept form. So just like in the last problems, I will do part A, and then I'll let you guys work on part B on your own. Okay, so here there are actually 2 ways that you could get to slope-intercept form in this case. Since it's asking for slope-intercept form, you could start with slope-intercept form. Okay, and the other way is to start with point-slope form and then convert that into slope-intercept form. So I'm going to show you both ways to do part A, and then once you guys get to part B, you really get the option of choosing which way you like the best. Okay, so part A, let's write it in slope-intercept form. The first step in either way is to find the slope. So the first thing you need to do is find the slope, and so that means that you need to find 2 points on this line. So I see 1 point right there right away. Okay, you should be able to see that one. It's 0, negative 3. 0, negative 3 for that one. And then do I see another point? Let's follow along until I see a point right there. Remember, you're looking for points that are on these, where these grid lines cross. We call these lattice points. Okay, so when you see a point right on a lattice point, that's the one you're going to use. So I see this one right here. I also see another one up here. Okay, so I'm going to use this one, which is negative 1, 1. Using that, I can find the slope. And remember, I said no matter what method you're using, you have to find the slope first. Okay, so to find the slope here, I'm going to find the change, just like I've been doing. So find the change in the x's, and then find the change in the y's. So for the x's, it looks like I am going from negative 1 to 0, which means a change of plus 1. For the y's, it looks like a change of from 1 to negative 3, so I'm going to the left. That means minus 4 is what's going to get me there, right? Start at 1, left 4, you end up at negative 3. So that means that the slope is negative 4 over 1, which is basically negative 4. Okay, and that is the half of your work is already done, finding the slope. Okay, the second part of your work is to find the y-intercept, to find B. Okay, so we're looking for B. There's multiple ways that you can find B, and I'm about to show you actually 3 ways of finding it. Okay, method number 1 would be to write the slope-intercept form of the equation, y equals mx plus b. So here we'll stop right here. And method number 1 will be to write y equals mx plus b. Substitute in the slope that you just found, which is negative 4 for m. And then for x and y, substitute in one of the 2 points that you used right now. Okay, so I'm going to use 0, negative 3. So I substitute in 0 for x and negative 3 for y. And then I solve for b that way. And that one should be pretty easy to see that the negative 4 and the 0 will cancel, leaving you with b equals negative 3, or negative 3 equals b. Method number 2, to write the equation is to start with point slope form. Substitute in the slope, which again is -4. And then for x sub 1 and y sub 1 right here, y sub 1 and x sub 1, again pick one of the 2 points that you used before. So once again I'm going to use 0, -3 and substitute them in place of x sub 1 and y sub 1. So x sub 1 will be -3. So what this will have is x sub 1 will be 0, sorry, 0 for x sub 1. So that'll be x minus 0 right there. And on the left side, y minus y sub 1. Y sub 1 is -3, so what you'll have is y minus -3, like that, which together will become +3, right? So you have y plus 3 is equal to -4 times x minus 0, which is basically x. And then what you do here is you will subtract 3, and that'll give you your equation. Y is equal to -4x minus 3. Okay, that's just to show you guys that you can start with slope-intercept form, you can start with point-slope form. Okay, however, the easiest way to write the equation is to look at the graph. Okay, use what you have, and if I just look at the graph, I found the slope, -4, and then I look at the graph and try to see if I can figure out what the y-intercept is. Where does the graph cross the y-axis? You should be able to see that it crosses at -3. Therefore, b equals -3, and so I can write my equation simply as y equals mx -4x minus 3 plus b. Either way that you solve this, you will get the same answer. Same solution, same equation. Okay, go ahead and work on b on your own. Find the equation of that line. The route I suggest you go is to find the slope, just like I did here, and then just look at the graph to see if you can figure out what the y-intercept is, and then just use those two values to plug it into y equals mx plus b. Okay, go for it. Okay, so here you go. Here's the correct solution for part B. I used the point 1, 2 and 0, -3. I found the rate of change, which is the slope, which is 5 over 1. Then the y-intercept I simply found by looking at the graph and figuring out what that point was, which is -3, right? It crosses the y-axis at -3. That's your y-intercept. Then I use 5 and -3 and substitute them both into y equals mx plus b to get y equals 5x minus 3. Okay, number 50, write the linear equation in slope-intercept form, then identify the slope and the y-intercept. So this equation right here is written in standard form. This one down here is written in point-slope form. Both of them need to be written in slope-intercept form. Okay, so let's recall that slope-intercept form is y equals mx plus b. Oops, plus b. Right, y equals mx plus b. So we need to write them both in that form. Let's start with A. A is in standard form, and what I want to do is isolate the x, right, the y. You want the y to be by itself. So the first thing I'm going to do is get rid of the 6x right there. So I'm going to subtract it. Subtract 6x from both sides. These cancel, and that leaves me with -7y. On the right side, do not combine the -14 and the -6x, right? They are not like terms. We call that a rookie mistake. Do not make that mistake. You're going to write them separately. And then you're going to divide by -7 on both sides. And so you will have y equals, now on the right side you have -6 divided by -7. Negative divided by negative will be positive, so it'll be 6 over 7. You can't really divide that, so just leave it as a fraction, but turn it positive because it's a negative divided by a negative. 6 over 7x. Now you can write the x right there in front of the fraction, or you can write it in the numerator next to the 6, and that would be still correct. Okay, and then -14 divided by -7, because you're taking this -7 and you're dividing both of the terms by it. Negative divided by negative will be a positive, and 14 divided by 7 is 2. There you go. And now what you need to do is identify the slope and the y-intercept. By looking at this, the slope would be m, which is next to x, so it'll be 6 over 7. And the y-intercept would be b, which is this number at the end, so it'll be 2. So the answer to the question is the slope is 6 over 7 and the y-intercept is 2. Okay, go ahead and try B on your own. I'm going to let you guys try B on your own. Remember, the goal is to isolate the y. You want the y to be by itself, and you want the right side to be mx plus b. You want it to be in this format, okay? Try it. Go ahead. I know there's a fraction, and some of you guys struggle, but go ahead and try it, and then come back, and I'll show you the correct way of doing it, okay? So go ahead and take a few minutes to try it, and come back. Okay, so hopefully you already tried doing it on your own. Let me show you guys the correct way of, or one of the correct ways. There's never one correct way of getting the correct answer here. So what I'm going to do first is I want to isolate the y, right? I want the y to be by itself, and I want everything else to be on the right side. The first thing I'm going to do is get rid of the parentheses, right? In slope-intercept form, there are no parentheses. So to get rid of these parentheses, I'm going to distribute, okay? So let's distribute the 5 over 6. You're going to multiply times that one and then times that one. Okay? So if you do that, you're going to have y minus 8 is equal to 5 over 6x plus 5 over 6 times 6. Right? 5 over 6 times 6. What's going to happen with 5 over 6 times 6 is that the 6's will cancel, leaving you with just 5. So what you have is y minus 8 is equal to 5 over 6x plus 5. No fractions. All right, I'm going to continue up here. Now next, remember I want y equals mx plus b, so I want the y to be isolated, so that what I'm going to do next is get rid of the negative 8 by adding it, right? Inverse operations there. So I'm going to add 8 to both sides. I'm going to go ahead and write it here. Add 8. Barely fits, but I'll write it there. And then so what you'll have on the left side will be y, the negative 8 and the positive 8 will cancel, equals 5 over 6x plus 13. And there you go. That's slope-intercept form. And now we answer the question, what is the slope and what is the y-intercept? And you should see that the slope is 5 over 6, right, next to x, and the y-intercept is 13. Okay, 51. Identify the point and slope used in the linear equation, then graph the line represented by the equation. Okay, so you have an equation in point slope form, and it's asking us to graph by identifying the point that was originally substituted in and the slope of the equation. Okay, so first, the easiest thing to find right here, okay, you know what, before I do that, I'm going to write the point slope form because some of you guys might not be that familiar with it or might not remember what it looks like. Y minus y sub 1 is equal to m times the quantity x minus x sub 1. Right? That's point slope form, where m represents the slope and y sub 1, I mean x sub 1, y sub 1 represents a point that this line passes through. Okay? So using that, the first thing that I identify and the easiest thing to identify is the slope. It's this number in front of the parentheses, right? So right here I can see it right away. The slope is negative 4 over 5. What might be challenging for some of you guys to identify is the point that it passes through. Okay, the point that it passes through is given by x sub 1, y sub 1, right? So it's going to be an ordered pair represented by x sub 1, y sub 1. And so you got to compare this equation that they have given you to the point slope form and think, what is x sub 1? Okay, well, it's obviously right here in this number, right? But it says x minus x sub 1, so there should be a negative right here, x minus x sub 1. Since there is no negative right here, there is a positive. That gives you the clue that the sign of this number will actually be the opposite of the actual coordinate. Okay, so instead of x minus x sub 1, it says x plus 3. So you got to think, oh, well, that's plus 3 is because the coordinate was negative 3, and so it was x minus negative 3. So really what they have right here is that And that became x plus 3, which tells you that x sub 1 was negative 3, not positive 3. And you do the same strategy for y sub 1. Y sub 1 is here, and it should be y minus y sub 1. So you see that the signs are the same right here. That means that y sub 1 is basically just this number, 1. And there you go. That's the point that it passes through. Now, how do we graph that? We are going to graph it simply by first finding this point and then using the slope for instructions. So let's do it. Find this point first, negative 3, 1, and plot it. Negative 3, 1 is right here. And then use the slope as instructions, right? Negative 4 over 5 means go down 4 to the right 5. So from that point, I'm going to go down 4, 1, 2, 3, 4, right 5, 1, 2, 3, 4, 5. So I will end up right here. Right there. Down 4 to the right 5, lands me right there. And then I connect them and I'm done. There is my line. And there's your equation of your line. Okay, 52 says write the equation in either, ooh, I like that, either point slope form or slope intercept form. I like to see that because that means I have the option. I could write it in whichever form I want. Okay, so either point slope form or slope intercept form. I'm going to write both forms right here so that we can choose the correct one based on the situation. That's slope intercept form, and that's point slope form. Okay, so in part A, it's telling me that the line has a slope of 5 over 3, so they're telling me the slope makes my job easier. And it has a y-intercept of 17. So they're telling me the slope and the intercept. That's the information they're giving me. The slope and the intercept. Which form do you think is best to use? Point slope form? No, slope intercept form, right? Because they're giving me the slope and an intercept. So I'm going to use this. So I'm going to write y equals mx plus b here. And in place of m, I'm going to substitute in the slope. And in place of b, I'm going to substitute in the y-intercept. And I'll be done. So it will look like this. Y equals 5 over 3x plus 17. Done. That's how simple that one was. Part B. A line passes through the point negative 7, negative 6 and has a slope of 3. So look at the information they give you. A point and the slope. Which form makes sense in this case? Point slope form, right? They give you a point, they gave you the slope, so we're going to use this one right here. Okay, so it will look like this. Y minus y sub 1 equals m times the quantity x minus x sub 1. In place of m, I am going to write the slope, which is 3. In place of minus x sub 1, I am going to plug in negative 7. So minus negative 7, think about the way that works, and you should see that it actually gives you x plus 7. Okay, so think about it. Negative 7 goes here. There's minus right there. So minus negative 7 will become plus 7. And then on the left side of the equation, minus y sub 1, think minus negative 6, so that will give you plus 6. And there you go. That's your point slope form. All right. I just drank a coffee, and I am full of energy now to continue this. So hopefully you guys are still here and still following along. Here we go. Number 53. Graph the linear equation. Y equals 5 over 4x plus 5. So first, identify which form they gave you the equation in. This is slope-intercept form, right? Y equals mx plus b. So if they give you slope-intercept form, what you need to look for is, what's the slope? Let's write it right here. not in that color. Let's write it right here, 5 over 4. And what is the y-intercept? 5. Right? You should be able to identify those by now. The slope is right in front of the x. The y-intercept is this number at the end, plus 5. So that's b. Okay? Use those 2 points to graph. So I start at positive 5 on the y-axis every single time. You never begin on the x-axis unless you have the intercept, the x-intercept. But you rarely have the x-intercept. You will have the y-intercept 99% of the time. So begin at 5, and then the slope is 5 over 4. Those directions, if you think of this as instructions, is saying go up 5 to the right 4. However, I have no more space to go up 5 to the right 4. So once again, like we did in previous problems, we're going to do the exact opposite. Instead of going up 5, right 4, I'm going down 5, left 4, and I will end up right here. So down 5, left 4 will give me a point right there. And that's it. Connect your points and you got a line. Boom, done. Part B. Part B is a little different because it's not in point slope form. It is in, it's not in slope intercept form. It is in point slope form. So let me write point slope form right here again for you guys. Y minus y sub 1 equals m times the quantity x minus x sub 1. See, that looks like point slope form. So when they give it to you in point slope form, you're not going to find the slope and the y-intercept. You're going to find the slope and a point that it passes through. Okay? So what is the slope of this line? That one should be very easy to see. It's the number in front of the parentheses, which is this. Now that negative is attached to an actual number, right? That's the invisible 1. It's negative 1 right there. So the slope is negative 1. Okay? And then you're not going to find the y-intercept, but you will find a point. That's why this is called point slope form. A point that is given by x sub 1, y sub 1. So you're thinking, what point does this graph pass through? What you're going to do is look at these numbers right here and think, what is x sub 1 here? It's not negative 1. Remember, it's always x minus x sub 1. So if you don't count the minus, x sub 1 is just 1. And then what is y sub 1? It's not plus 3, right? It's going to be the opposite of that, which is negative 3. So always think that these are going to be opposite signs because you're subtracting them. Negative 3. There you go. Graph it by first finding that point, plot it, and then use the slope. So here we go. 1, negative 3 is right here. And then the slope is negative 1, which as a fraction, I can write that as negative 1 over 1, right? Let's write it like that. Negative 1 over 1. So that means that the instructions are to go down 1. That means down 1, and that means right 1. Down 1, right 1. So from this point, I'm going down 1, right 1, right there. I'm going to do it again, and I get that. Connect those dots, and you have your line. You could draw more points by going in the opposite direction. Up 1, left 1. Up 1, left 1, up 1, left 1, up 1, left 1, up 1, left 1, and so on. That way you have a more accurate line. So here we go. Connect those dots. And boom, we're done. Okay, here we go. 54. A line passes through the points 6, 0, and negative 10, 32. Write the equation of the line in point slope form and slope intercept form. So they want both, okay? We are going to start with point slope form. We'll do that one first. Okay, so point slope form, once again, is y minus y sub 1 equals m times the quantity x minus x sub 1. Using that equation, the first thing I'm going to find is the slope. So to find the slope, what I'm going to do is I'm going to stack my 2 points. 6, 0, and negative 10, 32. I'm going to find the change. From 0 to 32 is plus 32. From 6 to negative 10, be very careful with that one. You're going from positive 6 all the way back to negative 10. That's negative 16. So that means that the slope is 32 divided by negative 16, which is negative 2. So we're going to use that. Next, you need to identify and choose a point. If we're using point slope form, you need the slope. We just found it. And you need a point. We have two to choose from. Just choose one. Doesn't matter which one. Just choose the one that you like the best. Okay. I'm going to use this one because it has a 0 in it. Any point that has a 0 in it is always going to make your job easier. So using 6, 0, I'm going to label 6, 0 as x sub 1, y sub 1. And so for x sub 1, I'm going to substitute in 6. And for y sub 1, I'm going to substitute in 0. Okay. So into my equation, which I am now ready to write, it's going to look like this. Y minus y sub 1, whatever that is, equals m times x minus x sub 1, whatever that is. Right? Plug in those numbers. I know m is negative 2, right here. I know x sub 1 is 6, and I know y sub 1 is 0. Clean it up and you are done. The equation looks like this. Y minus 0 is equal to negative 2 x minus 6. You can leave it like that. It actually is okay like that because it is in point slope form. Although since it says y minus 0, do we really need to write that? No, so you can just write it as y is equal to negative 2 x minus 6. So it's fine if you leave it like that. That's point slope form, but it's also fine if you leave it like that. Now the second part says to write it in slope-intercept form. Okay, since you already have it in point slope form, just keep going from there. Distribute, and you will turn it into slope-intercept form simply by distributing. Okay, so I'm going to distribute the negative 2 here, right there. So I'm going to get y equals negative 2x. Negative 2 times negative 6 will give me positive 12. And that is slope-intercept form. Okay, so both of the two first ones that I put in a box are point slope form. The last one is slope-intercept form. Okay, 55. A line passes through the points negative 6, 28 and negative 3, 18. Write the equation of the line in slope-intercept form. Okay, and then in standard form. Okay, so we're going to do slope-intercept form first. Okay, at this point you have the option of, if you want, to start with point slope form, then convert it to slope-intercept form, then convert it to standard form, which is the way that most people go. Okay, it's a process that just flows easily that way. So we're going to do that. Let's start with point slope form. Although they're not asking for point slope form, but it always makes the process flow easier if you start here and then convert it to slope-intercept form and to standard form. So using point slope form, first of all, what I'm going to do is find the slope like I always do. So it's going to be negative 6, 28 and negative 3, 18. And you think, what's the change on each one of these? The change from negative 3 to negative 6. Again, be careful with those. Think the number line. You're at negative 3 and you want to get all the way to negative 6. You're going left 3, so minus 3. From 18 to 28, you're going plus 10. So the slope is 10 over 3. 10 over negative 3. So negative 10 over 3. Right? You could bring the negative to the front. All right, that gives you the slope. Next, you need to choose a point. Doesn't matter which one you use. You have two to choose from. I'm going to use negative 318. So I'm going to call negative 318 x sub 1, y sub 1. And so I'm going to use these two numbers and then the slope, substitute them into the equation. So I will have this. Y minus y sub 1 equals m x minus x sub 1. Right? In each one of those, I'm going to substitute in my correct numbers. So y sub 1 is 18. So 18 right here. M is negative 10 over 3. So negative 10 over 3 right here. And x sub 1 is negative 3. So x minus negative 3. So I'm going to plug in negative 3 right here. Okay, and now just simplify. We're going to have y minus 18 on the left side equals negative 10 over 3 times x. What's going to happen with minus negative 3 is going to turn into plus 3. And that's point slope form, but remember the question is asking me for slope intercept form. So what I'm going to do to change it into slope intercept form is to distribute and then add 18 to both sides. Okay, so let's distribute. That means you're going to multiply here and there. So you're going to get equals negative 10 over 3x minus, because it's a negative times a positive, right? Right here, I'm doing this one, which is negative 10 over 3x, and then over here, negative times positive will be minus 10 over 3 times 3. And what's going to happen with the 3 and the 3 is that they're going to cancel. So you're going to have negative 10 over 3x minus 10. That's the right side. The left side will be y minus 18 all the way through. Okay, that's still not slope-intercept form, right? Slope-intercept form means y equals mx plus b. I want the y to be by itself, so I'm going to add 18 to both sides. And when you do that, you'll end up with y equals negative 10 over 3x. Negative 10 plus 18 will be plus 8. Done. That is slope-intercept form. Now, it's also asking me for standard form. Okay, so to write it in standard form, I'm going to start up here, right? I took my slope-intercept form equation, I put it over here, and I'm going to convert that to standard form. The first thing you got to do when you want to put it in standard form is to move the x's and the y's have to be together, right? X and y are both together on the left side. So since I see that the y is over here on the left side already, I like that. But this one needs to go over to that side. So I'm going to add 10 over 3x, and that will make it move or go over to the left side. What happens is that these are going to cancel, right? On the left side, I will have y and 10 over 3x. They cannot combine. They're not like terms. So you're just going to write them separately from each other. You're going to write 10 over 3x plus y equals 8. Now, technically, that is standard form. However, most of the time we ask you for standard form, we want coefficients that are integers. This is not an integer. This is a fraction, right? It's a ratio. So we don't want those. We want an integer in the front most of the time that we ask you for standard form. So in order to do that, I am going to get rid of the fraction by multiplying all the way through by 3. Why 3? Because 3 is the denominator of that fraction, so when I multiply by 3, it will cancel. So what's going to happen is you're going to multiply 3 times this one, which will basically just cancel the 3, leaving you with 10x. And then you're going to multiply 3 times this one, which will give you 3y. And then you're going to multiply 3 times 8, which will give you 24. And there you go. That's standard form. All right, let's start with 56. It says the clothing store sold paintings for $30 each and beanies for $36 each. The total revenue made from selling these items was $360. Write a linear equation that represents the given information. Explain the meaning of each variable. Okay, so first let's start with explaining the meaning of each variable. Since this clothing store is selling paintings for some reason, I don't know why the clothing store is selling paintings, but okay. If this clothing store is selling paintings, we're going to call P the number of paintings that they sell. And we're going to call B the number of beanies that they sell. Okay? And so how much are they making for the paintings? If you think about it, they're charging $30 for each painting. So for the total number of paintings, which is P, they are going to make 30P. 30P represents the total amount of money they make for the paintings. Okay? On top of that, they are selling beanies. So you're going to add to that, and they're selling beanies for $36 each. So if each beanie is $36 each, the total amount of money they make from beanies is going to be 36B. Because you can multiply 36 times the number of beanies to get the total. Same thing for the paintings. $30 times the number of paintings equals the total. The total revenue made from selling these items was $360. So when you add these two items together, you're going to get $360. That's the total amount. Okay? And that's part A. Part A simply says write a linear equation that represents the given information. Explain the meaning of each variable. We just did everything. Here's the equation. And each variable, the B represents the number of beanies and P represents the number of paintings. Okay, part B says graph the equation and label both axes. So right here, as you can see, in my graph, they used X and Y, right? Not P and B or B and P. So I need to decide which one of these is going to be my X and which one of these is going to be my Y so that I can graph it. Okay, since I see more numbers on the x-axis, I believe I'm going to use X for P, and B will be represented by Y. And that should help me graph it. So if I change this equation to 30P, which is 30X, plus 36Y equals 360, I now can graph it. Okay, so in order to graph, I'm going to change it into slope-intercept form, just the form that we always like for graphing. I'm going to subtract 30x from both sides. I got 36y is equal to negative 30x plus 360. 360, not 30. Now I'm going to divide by 36 on both sides. And now I have y equals negative 30 over 36. That's negative 30 divided by 36. Well, you're going to get a decimal, but we don't like decimals when we're graphing. We want a fraction. So just simplify that fraction. 30 over 36, what do they have in common? 6. So divide both by 6. You're going to get negative 5 over 6. X. Plus 360 divided by 36 is simply 10. So plus 10. There you go, ready to graph. So now when I look at this graph, B is 10, which means I will begin at 10 on the y-axis. And X, the slope is negative 5 over 6, so I'm going to go down 5 over 6. Okay, so here we go. From 10, I'm going down 5, 1, 2, 3, 4, 5, and to the right 6. So I'm going to end up at 6, 5, right here, right there. So let's put the point right there. And I'm going to keep making more points. I'm going to go down 5 over 6 again to end up right here at 12, 0. And there's your line. Now, this line does not keep going past the x-axis or the y-axis, okay? Because then that would mean that you're buying a negative number of beanies or a negative number of paintings, which wouldn't make sense, okay? Now, make sure you're paying attention to the instructions. It says label both axes, so we got to figure out which one is which. We already did that before. We said that x is P, so right here on the x-axis is the number of paintings. And up here on the y-axis is the number of beanies. And that's your final graph. Okay, and part C says use the graph to approximate the number of beanies sold if 8 paintings were sold. So basically, what happens if 8 paintings, this one represents paintings, what happens if 8 paintings were sold? Approximately how many beanies does that mean? So what you do is you got to find 8 on the x-axis, because that's paintings, and then go up until you reach your line and approximate what that is, what that means in terms of beanies. Okay, approximately how many beanies are sold if 8 paintings are sold? Well, looks like that goes 3.5, I think a little bit above 3, so maybe 4. We can say it's either 3 or 4, which are both pretty good approximations. Okay, 3 or 4. So it looks like approximately 3.5, but we're going to round up because you can't sell 3.5 beanies, right? That wouldn't make sense. Okay, 57 should be a pretty easy one for everybody. Okay, they already graphed the inequality for you, so all you have to figure out is determine whether these points are solutions to this inequality. And in order to do that, all you have to check is where these points are. Are they in the shaded region or are they in the non-shaded region? If they are in the shaded region, you're going to say yes, that is a solution. If they're not in the shaded region, then you're going to say no, that's not a solution. Okay. Well, what happens to be right in the middle, right on the line? Well, then that depends. If the line is solid and the point lands on it, then it is a solution because the solid line represents solutions. If the line is dashed or dotted like this one and the point is on it, then that means it's not a solution. The dotted line represents not non-solutions. Okay, so let's check these real quick. 1, negative 2. 1, negative 2 is right here. Is it on the shaded area? Yes, it is. Therefore, it is a solution. Okay, so 1, negative 2 is a solution. We're going to say yes. 4, negative 4. Let me graph 1, negative 2 though, so that you guys can see why I said yes, because it's in the shaded, it's right about there. 4, negative 4, 4 this way, and 4 this way. It happens to be right on the line. Now, since the line is dotted, that means that 4, negative 4 is not a solution. So no. Once again, the reason for me saying no is that the line is dashed or dotted, okay? So the point happens to land right on the line, but the dotted lines represents non-solutions, okay? If the line was solid, we would say yes. All right, and finally, negative 4, negative 4. Find it. 1, 2, 3, 4, down 4. What do you guys think? Obviously yes, right? That is a solution because it's in the shaded region right here, somewhere around here. I can't tell very well because the dots I can't see that well, but it's right here in the shaded region, so yes. Done. All right, let's move on to number 58. Okay, in this one I will do A and I will let you guys work on B on your own. So here you go. Part A, graph the inequality y is less than or equal to 5 over 3x plus 4. Since it's written in slope-intercept form, makes it very easy for me to graph. What you got to do is look for the slope and look for the y-intercept. And we've been practicing this. The slope is the number in front of the x, right? 5 over 3. And the y-intercept is this number over here, 4. Using those two numbers, I'm going to graph it. Starting with 4, begin at 4 on the y-axis. The slope is 5 over 3, which means go up 5, right 3. I'm out of space, like it's been happening in a couple of problems, right? So I can't go up 5 over 3, which means I'm going to do the exact opposite. The point is going to be somewhere over here, so it's actually going to be somewhere over here. Down 5 over 3, right around here. Okay, this is going to be your point. So instead of up 5, 3, go down 5, left 3. There you go. Now the last thing you check before you draw your line is to see if it's supposed to be dashed or solid. If you see the little equal sign underneath, that means solid. If you don't see it, like here, that means dashed. So this one's going to be solid. Okay, and last, we need to shade. Inequalities always need to be shaded. You cannot just draw a line and leave it. Okay, so if you see an inequality, there has to be some shading happening here. Okay, in order to decide which side to shade, we're going to check a number. Okay, so we're going to check the number 0, 0, which is always our checkpoint. Okay, that point is easy to plug in. So you're going to plug in 0 for x and 0 for y here and see if it makes it true. Okay, like this. So I'm going to write y is less than or equal to 5 over 3 x plus 4. I'm testing this point. This is my test point. Okay, you're really just choosing any point to test, but 0, 0 is the easiest one. If your line passes through 0, 0, then choose another point, but something with easy numbers like 0, 1 or 1, 0. Okay, so we're going to plug in 0, 0 into our equation, and it's going to look like this. 0 is less than or equal to 5 over 3 times 0 plus 4. Simplify that down and you're going to get 0 is less than or equal to 4. And then what you have to do is look at that and say, is that true? Is 0 less than 4? Well, 0 less than or equal to 4? Well, it's not equal, but it is less than. So you're going to say, yes, that is true. So, since 0, 0 is true, that means every other point on this side of the line will be true. So you will shade everything on this side of the line. Every single point on that side. Okay? What if 0, 0 had been false? What if I plugged it in here and I got something that was not true, like 4 is less than 0? Then you would say, well, since 0, 0 does not work, that means nothing else on this side works. So all the other points on the other side should work. Okay, and you would shade the other side. All right, try B on your own right now. Go ahead and pause the video. Do it on your own first, and then come back and check your answer. Okay, so here's the correct solution for part B. Y is greater than 5x minus 1. The slope is 5. The y-intercept is negative 1. So I began at negative 1 and then up 5 over 1. And then my line is dashed. Then what I did is I checked 0, 0 as my checking point. So I plugged in 0, 0 into my equation, inequality. And I got 0 is greater than negative 1. And that is true. 0 is bigger than negative 1 because negative 1 is more to the left on the number line. So since 0, 0 works, that means that 0, 0, which is above the line right here, is a solution, which means that everything else above the line on this side is a solution. So I shaded that side. All right, 59, graph the inequality. A, x is less than negative 3, B, y is less than or equal to negative 1. Okay, now these inequalities are special. They're different from the ones that we did before in 58, right? Whereas they don't look like they're in slope-intercept form, and so some people struggle or get confused. Okay, one strategy that I use to show my students what vertical lines and horizontal lines, because that's what these are actually going to be, is a little acronym that makes no sense, but it helps you remember the difference between vertical lines and horizontal lines, called HOI-VUX. Okay, and I know those words make no sense. They're not actual words. They're just acronyms. But the way you think about it is the H stands for horizontal. The O is actually a 0. Okay, that means that horizontal lines have a slope of 0. And the y represents what the equation looks like. The equation of horizontal lines is always going to be y equals or y is less than a single number. Okay, so for example, I'll just write a few right here. Y equals 3 is a horizontal line. Y equals 9 is a horizontal line. Y is less than 7, less than or equal to 7 is a horizontal line. And then VUX means that vertical lines have a slope which is undefined, and their equations always start with x equals a number. Okay, so for example, x equals 7, x equals 8. Or inequalities, x is greater than 5. Those are all vertical lines. Okay, these two simple words help me remember that and help my students remember it. So we're going to use them right here. And 59 part A, it says x is less than negative 3. According to this, x, that means a vertical line, okay, which has a slope which is undefined. So what you're going to do is on the x-axis, find negative 3. right there, and then just draw a vertical line. Before you draw it, check, is it supposed to be solid or dashed, because we still have to worry about that. This one does not have the equal sign, so it's dashed, like that. And then you're going to shade either the left side or the right side of that line, okay? In this case, it's really easy to tell. You can check 0, 0 again to see if it works. Plug in 0. I'm checking 0, 0. So plug in 0 right there for x, and you're going to see 0 is less than negative 3. And you think, is that true? Is 0 less than negative 3? Is 0 a smaller number than negative 3? And your answer should be no, right? 0 is greater than negative 3. So since 0, 0 does not work, none of these numbers work, which means I'm going to shade this side of the line. Everything on that side of the line gets shaded. Okay, for part B, y is less than negative 1. According to Hoy-Vux, that means it's a vertical line. So on the y-axis, because it says y is less than or equal to negative 1, on the y-axis, I'm going to find negative 1 right here. And I'm going to draw a horizontal line once again, right? Because it's y, so that I want a horizontal line that passes through there. So drawing a horizontal line that passes through that. Oh, I made it dashed, but look, it's supposed to be solid. So let's fix that. Draw a solid line instead. There you go. And then you're going to check 0, 0 again. Plug in 0 for y. Remember, the reason why we check is to decide which side to shade. So here's 0, 0. That means I'm going to plug in 0 for y right here. And I'm going to get 0 is less than or equal negative 1. And you again ask, is that true or false? Is 0 less than negative 1? And the answer to that is false, right? 0 is greater than negative 1. Therefore, I should not shade any numbers on this side, because that one didn't work. Nothing else on this side would work. So I will shade the numbers on this side over here. Okay? So I will shade every single point below the line. Okay, this will be the last problem on the part 3 of the review. Okay, this will be our last one right now. So it says 60, which equations describe parallel lines? Okay, so let's remember that parallel lines have the same slope every single time. Okay, so every time you see parallel lines, you think same slope or equal slopes. They have to have the same slope. So you're looking at these, and what you need to do is identify the slope to see if they have the same slope. Okay, if they do have the same slope, then you need to check, because they might be identical lines. Okay, you want parallel lines are lines that have the same slope, but they will have different y-intercepts. So let's look at one right here. If we think of y equals mx plus b to find the slope, that means that y equals right over here. If you think of it as in terms of y equals mx plus b, that means that m equals 4 in this one, right? The number next to x. In 2, once again, if you think of it as y equals mx plus b, it's already in that form, which means that m is negative 1/4 in that one. So 1 and 2 are not parallel. Those are different slopes. Let's look at 3. 3 is not in slope-intercept form. It's in standard form. So I can't tell what the slope is until I change it into y equals mx plus b. So let's rewrite it as slope-intercept form. So in order to change it into slope-intercept form, I want to isolate the y. So the first thing I'm going to do is subtract 12x from both sides. On the left side, that cancels, so you have negative 3y. The 6 and the negative 12x do not combine with each other. They are not like terms. Don't make the rookie mistake here. So you're going to write negative 12x plus 6. And then you're going to divide by negative 3 on both sides, and that'll give you slope-intercept form. Okay, on the right side, negative 12 divided by negative 3. Negative divided by negative will be positive. 12 divided by 3 is 4. 4x. 6 divided by negative 3. Positive over negative is negative. 6 over 3 is 2. And then that is slope-intercept form, which means that the slope is, do you see it? You should see it, 4. The number in front of x right there. Okay, and let's do the last one just to get them all done. 4y plus 4 times the quantity y plus 6 equals x minus 3. Once again, I'm going to change it to slope-intercept form. So in this case, the first thing I'm going to do is distribute the 4. Okay, so I'm going to distribute 4 right there, and I will get 4y plus 6. No, not plus 6, plus 24. When you're distributing, you need to multiply the 4 times the y, the 4 times the 6. Equals x minus 3. So I'm going to subtract 24 here to isolate the y. So 4y is equal to x negative 3 minus 24. Think about this carefully. That's negative 27. And then divide by 4. Okay, so when we divide by 4 on the right side, we're going to have, well, on the left side, we're going to cancel the 4's, right? So it's going to be y, going to continue up here, is equal to x minus 27. Now think of the x as 1x, right? I'm going to write it here just so you guys can see it. There's a 1x right there. So what I actually get is 1 over 4x minus 27 over 4, right? I'm dividing by 4 on both of them. And therefore the slope is 1 over 4. Okay, so once we have that, we can compare all of the slopes to see which lines are parallel. So line number 1, the slope is 4. Line number 2, the slope is negative 1 over 4. Line number 3, the slope is positive 4. And line number 4, the slope is positive 1 over 4. So the only two that I see that are the same are 1 and 3. Okay, now before you say yes, they are parallel, make sure you notice that the y-intercepts are different. This one, the y-intercept is 0. And this one, the y-intercept is negative 2. Therefore, they are parallel because they have the same slope, but they are not identical. They don't cross at the exact same spot. So the answer to this question is 1 and 2. One and 2. All right, so this concludes part 3 of the review for the final. Expect one more part 4, to be uploaded also later today. And therefore you will have 4 parts to finish all 72 problems on your review. Okay, keep studying and good luck.